So the second question that I decided to answer for my student-directed study was from the Impulse and Momentum unit. The question is, two objects are traveling perpendicular to each other, one moving at 2 meters per second with a mass of 5 kilograms, and one moving at 3 meters per second with a mass of 10 kilograms. They collide and stick together. What is the magnitude and the direction of the velocity of both objects? So this question gives us the diagram to follow. So we can see the 5 kilogram object is moving east at 2 meters per second. And we can see the 10 kilogram object is moving 3 meters per second north. They both collide and stick together and move off in northeast direction to some degree of an angle, and they move off at a certain speed. So in order to solve this question, our first step is to split what values we know into the x and the y components. In order to do this, we can look at our diagram and we see that in the x component, our first object is moving at 2 meters per second in the x direction. Now the second object, which is our 10 kilogram object, is not moving at all in the x direction. It is only moving in the y direction. So we know this for our x components. We can do the same for our y components. Our first object is not moving in the y component, and our second is moving at 3 meters per second in the y direction. And we know that our mass 1 is 5 kilograms, our mass 2 is 10 kilograms, and our total mass when they stick together is 15 kilograms because we add the two together. The second step in solving this question is to use the momentum and impulse formula for when two objects collide and stick together. So we have to solve for the total velocity in the x and y directions separately because they are separate before they collide. So in our x direction, we input the values that we have listed earlier on this sheet of paper. So we listed your initial velocity of the first and the initial velocity of the second in your x direction, and you input those values into the formula above. When you solve for your total velocity in the x direction, you get 0.667 meters per second east. Now when you solve for your total velocity in the y direction, you get 2 meters per second north. Now that you have your x and y components of your total velocities, you can use these to make a right triangle and solve for your hypotenuse, which is your overall total velocity. And you can solve for the angle at which the objects have moved off in the direction in your diagram. You can solve for this angle and this velocity. So, in order to do that, you need to use Pythagorean theorem. So you have your x and your y, so you need to square both of them and then square root your answer. So your overall total velocity is 2.1 meters per second. You need to use SOHCAHTOA to find your angle. So in this case, your opposite over your adjacent. So we use your 2 meters per second north divided by your 0.67 meters per second east is equal to theta, which is equal to 71.6 degrees. Overall, you have to include your sig figs, so your answer is east 72 degrees north, which means the collided objects are moving east 72 degrees up north. That's what that degrees means. So, including significant figures into our final answer, if we look back in our original question, there are only one, though there is one significant figure, which is the lowest of them all. So, our final answer is the magnitude and direction of both objects is 2 meters per second, east 72 degrees north, or 2 meters per second north 18 degrees east. The reason I included this second answer is because if you drew your triangle in the opposite direction, you would, you may switch your 0.67 to put on top of your 2 meters per second, and then you would get the other answer, which is the 18 degrees, but that would be in the opposite direction. It would be in the opposite direction, so you would actually be going north. You would be going north, and then you would be going 18 degrees east. So you would just, it would be like if you drew this the other way, your right triangle would be up here. So, yeah, so that's how you determine your magnitude and direction on a multiple, on your x and y component question in impulse and momentum.